Today we're going to start talking about graphing systems of linear equations and how we can use the calculator on Desmos to be able to verify solutions. So make sure you have this note sheet on your desk and make sure you have access to Desmos easily accessible for you to be able to practice as well. So I recommend going through and highlighting the important vocabulary in this note sheet so you have it all down. Let's go ahead and let's look at the first question. It says, what is a system of linear equations? A system of linear equations is two or more equations of lines, because it's a linear equation. It's two or more equations of lines on one coordinate plane. So systems of linear equations is two or more equations of lines on one coordinate plane. So I'm taking one coordinate plane and I'm graphing two or more lines on them. So lines, when you have more than one line on a coordinate plane, you have three technical scenarios. Those three scenarios can be, they would be parallel lines, right? Or those lines would intersect. Or one line could be stacked on top of another line. Those are really the three scenarios of graphing linear equations. So our goal with this, so I would highlight where it says goal. Our goal is to determine the ordered pair where the lines meet. So my goal in this whole unit is I'm going to take two lines and I'm going to determine where they meet. They meet in an ordered pair. An ordered pair is made up of what? Two values. They're made up of an x value and a y value. So I'm looking for what x equals and I'm looking for what y equals to determine if that's where my lines meet. Okay? So if I go ahead and I look at these examples, it says determine if the given ordered pair is a solution to the following linear equation. So I can solve this in a variety of ways. If I want to show that this ordered pair is a solution, all I would do is I would plug in 2 for x and 3 for y, and I would check my answers. So I would plug in 3 for y, and I'd plug in 2 for x, and I'd clean up the right side. So 3 times 2 is 6. 6 plus 2, does that equal 3? 6 plus 2 is 8. Does 8 equal 3? No. So no, it is not a solution. If I were to come over here and look at this example, I'm going to plug in negative 6 for x and 2 for y. So I have 3 times negative 6 plus 12 equals negative 2 times 2. So I have negative 18 plus 12 equals negative 4. Just multiply that out. And negative 18 and negative 12, that makes negative 6. Negative 6, does that equal negative 4? No. Another way I could have checked my answers, if I go over to Desmos, so if I go over to Desmos and I click on this, and I were to type in this equation right here, and I were to type in y equals 3x plus 2, and then if I were to graph that ordered pair, so if I come down to line 2 and I type in 2, 3, notice that blue point. That blue point is not on my red line, so obviously it's not a solution. If we go ahead and we try that with an example 2, if I type in 3x plus 12 equals negative 2y, and then I come down to line 2 and I type in the ordered pair negative 6, 2, notice is negative 6, 2 on my line? No, which is why it's not a solution. So hopefully that makes sense. In order for something to be a solution, it has to be on the line. So when we were using the calculator, there were these really nice, awesome steps, which were like 12 different steps to be able to plug numbers into your equation to be able to check it quicker. So now we're not going to do that. I'm going to simply say no longer need. We're going to use Desmos. Use Desmos. So notice on those examples above, I showed all my work. But if I come over to Desmos and I delete my screen, and I come over here and I type in that just the X value. So if I say, and I can even write it out. So if I can say 6 equals -5 plus 1, right? So yeah, you can just type in, you don't have to show work. -5 plus 1, that's -4. Does 6 equal -4? No. So it's not a solution. So I want you to try number 2, either method. Those 2 methods can either be plugging them in, like we did those 3 examples, or doing it on Desmos. Pause this video, do number 2. When you finish, unpause this video, and I'll go over it. So I'm going to do this example using Desmos. I'm going to type in 8y minus 5x equals 4. Here's my line. And I want to type in my ordered pair 4, 3. And notice that blue point is on my line, so I should say yes. If I do this the hard way, or the longer way, maybe it's not necessarily hard, I'm going to plug in 3 for y and 4 for x. So I get 24 minus 20. I want to know if that equals 4. 24 minus 20 is 4. Sure enough, that works. Okay? So now, these were just equations of lines. Let's look at what a systems of equations looks like. These 4 examples down below are examples of what systems of equations look like. There are 2 equations of lines, and I want to know where they meet. That's my goal. So this value right here, I want to determine whether or not those values are where they intersect. So how do I determine if those values are solutions? If I do this by hand, I'm going to have to plug -4 in for x and -6 into y into both equations, and I have to say yes, yes on both equations. If I plug -4 in for x and -6 in for y, and I don't get yes, yes on both equations, that means it's not a solution. So if I show you what I mean, I'm going to take the top equation, and I'm going to plug -4 in for x and -6 in for y. So I have -4 minus 12. So that's -16. See if -16 doesn't equal 9? I'm going to instantly say no, it's not a solution. Okay? If I go down and look at number 2, I'm going to plug in -1 for x and -2 for y. So I'm going to do 7 times -1 plus 5 times -2. I want to know, does that equal -3? So 7 times -1 is -7. 5 times -2 is -10. Does that equal -3? -7 minus 10 is -17. That sure enough does not equal -3. So no, it's not a solution. If I come over and I show you how to do this on Desmos, I'm going to go back to example 1, and I'm going to type 1 equation into line 1 of Desmos, and I'm going to type 1 equation into line 2 of Desmos. So I'm going to type in the first one, x plus 2y equals 9. And I'm going to type in -3x plus y equals 6 in the other one. If you want to then type in that ordered pair, you can. Notice my black point is only on my purple line. It has to be where those lines intersect to be able to determine the solution. So since this point right there does not show where those 2 lines intersect, that would be no, not a solution, which is why I wrote no. If we go ahead and we go down to number 2, I'm going to type in 7x plus 5y equals -3, and -9x plus y equals -11. And if I even want to type in the ordered pair, -1, -2, notice that green dot is not on either of my lines, so I would have gotten no on either line I plugged in. Okay? So if you go ahead and I want you to pause this video and I want you to try example 3 and 4 on your own. I want you first to do it the algebraic way, just like we did here showing work, so we can make sure that you got your answers. And then if you want to check it with Desmos, that's completely fine. But keep in mind that if you don't show work, you don't receive full credit, so I want to make sure you do that. When you finish, you can unpause this video and I will have the answers on the board. So I'm going to go ahead and I'm going to do this through Desmos. I'm going to plot 3, 3. Notice the point red 3, 3 is where those two lines intersect. So I should have said yes for number 3. Number 3, I should have said yes. And if I go ahead and I quickly do example 4. And I put them here, -4, -6. Notice it's not on either one, so I should have said no. Okay? So hopefully you're okay with this, and if you're good, go ahead and flip your paper. So if we look at this, we have 3 different ways in which we can solve systems of equations. I would highlight this because it's important. The 3 different methods in which I can do. First method is graphing. The second method is the substitution method. And the third method is the elimination method. Graphing is obviously graphing y equals mx plus b. Substitution is when I take one equation and I substitute it into the other equation. And the elimination method is when I eliminate one of my variables. If you look at these equations up here, you should have seen I had 2 equations, and I have 2 x values and I have 2 y values. That's how I'm going to eliminate. I'm going to end up eliminating one to be able to find the other. So those are the 3 methods. So the other videos of this unit discuss each method individually. So you can go ahead and pause this video, and if you are required to go to the next video, please do so.